Good morning, good afternoon, and good evening, philosophers, and welcome to video 7 of Philosophy of Science through the lens of medicine. Last time, we used Eddington's two tables example to separate appearance from reality, the world as it shows up in everyday life, and the stranger world science describes underneath. Don't worry, we're not going to knock on that table again. The poor thing has suffered enough. Today, we ask the next question. When science gives us that deeper story, should we believe it? Should we think it's literally true? When a doctor says your infection is caused by bacteria, when a geneticist talks about a mutation, when a neuroscientist talks about neural pathways or cognitive reserve, are these descriptions of what's really going on, or are they just very useful models that can help us predict, treat, and organize what we observe? This is the scientific realism debate. It sounds abstract, but it is everywhere in medicine. Every time we say, this drug works because it targets this mechanism, we're doing more than just listing symptoms. We're making claims about hidden causes. So, first, scientific realism. The scientific realist says, take our best science seriously, not blindly, not fanatically, not I have a shrine to the electron seriously, but seriously. If a mature, successful scientific theory says that there are viruses, genes, neurotransmitters, immune responses, or subatomic particles, then we have good reason to believe those things really exist. Realism usually comes with three commitments. First, there is a world out there that exists independently of us. Reality is not waiting politely for our permission. Second, scientific language is usually literal. When scientists talk about viruses or electrons, they're not just telling bedtime stories for lab coats. Third, our best scientific theories give us knowledge of that hidden world. Not perfect knowledge, not final knowledge, but approximate, corrigible, hard-won knowledge. The realist's favourite argument is the no miracles argument. Modern medicine works disturbingly well for something that's supposed to be just a useful fiction. Antibiotics treat bacterial infections. Vaccines train immune systems. Imaging technologies guide surgeons, and anaesthetists stop you noticing that someone is rearranging your knee. The realist says, if the underlying entities and mechanisms were not at least roughly real, then why does all this work? If bacteria, genes, immune cells, and biochemical pathways are just convenient stories, then the success of medicine starts to look like the world's most elaborate lucky guess. And philosophers, being philosophers, are allergic to miracles, unless they can get a seminar series out of them, of course. So realism says the best explanation for the success of science is that our theories are latching on to reality. Now enter scientific anti-realism. The anti-realist is not anti-science. This is really important. Anti-realism isn't throw away your antibiotics and trust moon water. It's more cautious view about what we're entitled to believe. The anti-realist says science is brilliant at prediction, organization, and practical control, but that doesn't automatically mean our theories reveal the deep furniture of the universe. One version is instrumentalism. On this view, scientific theories are tools. A theory is like a stethoscope, a calculator, or a very expensive hospital printer that occasionally works. You don't ask whether it's true in some ultimate metaphysical sense, you ask whether it does the job. A more refined version says, accept theories when they accurately describe what's observable, but stay agnostic about the unobservable machinery behind the scenes. In medicine, that sort of means that you might trust a theory's predictions and treatments without committing yourself to the claim that its hidden mechanisms are the final truth about reality. The anti-realist's big first argument is history. Science has a slightly awkward museum in the basement. It contains theories that were once taken very seriously, like humoral medicine, miasma theory, phlogiston, caloric, the ether. These weren't all silly ideas believed by people too dim to own a pipette. Many were very successful, respectable, and useful in their times, and yet now we reject them. So the anti-realist asks, if past successful theories turn out to be false, why assume our current successful theories are immune? Perhaps future scientists will look back at some of our current favourites with the same affectionate embarrassment with which we look back now at balancing the four humours. The realist says, but our science is more mature. And the anti-realist replies, that's exactly what the last lot said. The second big anti-realist argument is underdetermination. The basic idea is that evidence doesn't always point towards just one theory. The same observable data can sometimes be explained by more than one deeper scientific story. Doctors know this pattern well. The same symptom can fit several diagnoses. More tests narrow the field, but the raw data don't arrive wearing a badge saying, "Hello, I'm the one true explanation." In science more generally, the worry is that different theories might predict the same observations while telling different stories about what's happening behind the scenes. If that's possible, then observable success alone might not prove what the hidden story is really all about, which is true. So we get a wonderfully irritating stalemate. The realist says science is too successful to be merely useful fiction, and the anti-realist says history shows that successful science can still be false. The realist says, but the best theories explain, unify, predict new phenomena, and let us intervene. And the anti-realist says, excellent, use them, just don't confuse usefulness with truth. And this is where the debate comes really interesting, because the real realists aren't saying, believe every sentence in today's textbook forever. They're usually more selective. They say we should be realist about the parts of theories that genuinely earn their keep, the bits that explain success, generate new predictions, and survive serious testing. The best anti-realists aren't saying science tells us nothing. They're saying, let's not inflate success into certainty about ultimate reality. So this is the question for medicine. When medical science posits hidden causes, viruses, genes, neural mechanisms, risk factors, cognitive reserve, all that kind of stuff, are we discovering the real structure of the body and mind, or are we building models that work well enough for prediction and treatment, and just models alone, not reality? Next time, we're going to consider this debate using cognitive reserve. Is cognitive reserve a real feature of the brain, a useful clinical model, a convenient label for patterns we don't yet fully understand, or, like many things in philosophy, is the answer annoyingly, it depends? For now, I want you to try and choose a side. Are you more realist or anti-realist about science? Which argument moves you more, the success of medicine or the graveyard of discarded theories? Please state your view in the comments below and explain why. Like and subscribe, and I'll see you on the next one.